Okay, let's get started. Can you all hear me okay? Can you all hear me okay?
Yes.
Yes, we can hear you.
Okay, thank you.
Yes. Good.
Yeah, thank you. Okay, so we talked a little bit about our class overall introduction last week, and we also tried to make a website last week. And starting from this week, we will introduce you all to AI mindset. Basically, this is divided into three parts. So part one is what is AI? We will try to give you a rough idea of what is AI. And the part two is what problems can AI solve? And the part three is a hands-on project. So it'll be super fun. Yeah, and I'm also very excited about that part. But before that, we let's first touch base on what is AI. Can someone volunteer to answer this question? So what is AI? You can unmute yourself. I have put something over here, but you might have your own idea. Xuan Xuan, do you have some comments? What is AI, or what does AI mean to you? Xuan Xuan? Okay, anyway. So basically, AI is short for artificial intelligence. So what does intelligence means to you? Do you think, or what is intelligence? Harvard? Can you give some comments? What is intelligence?
Intelligence is being smart.
Being smart? That's a very good question.
Yeah.
A very good answer. Thank you. So intelligence means being smart. So what is the most intelligent kind of all over the universe? What do you think? 橘子老师。
没有，是啊，
小鱼。
你告诉他。
不要。
Can you repeat the answer question again?
Yeah, what is the most intelligent kind of all the universe, or you have ever seen? What is the most intelligent?
Computer.
Computer? A computer is intelligent. Yes, sure.
Human?
Yeah, exactly. I think human is the most intelligent species of the whole world, and might be the whole universe. So human is smarter than anything else, right? So intelligent basically means that you have the ability to percept, to perceive, to reasoning, to think, to come up with a lot of creative ideas. So basically, human is the most intelligent species of the whole world. But what about artificial intelligence? Artificial means, well, something that is fake, right? So something that is fake, that means that it is trying to mimic something. It is trying to simulate something. And what is simulate is basically human. So artificial intelligence is basically telling you that we are trying to teach computer to learn from human and try to mimic human so that it looks like human. Then you can think about it. Well, what does artificial intelligence do? Well, because human can think, then artificial intelligence can think. Because a human can talk, then AI can talk. And human can play games, and AI can learn to play games, and so much more. So you can think about what else it can do. So I have a question here. Can you name a few AI applications around you, or what you do, what you see every day? Anyone want to volunteer?
Alexa.
Alexa, yeah, great. So Alexa is like a AI assistant, right? So basically, it helps you setting reminders, dealing with a lot of things, etc. Alexa, Siri, yeah, all these are AI assistant. So anything else?
ChatGPT.
Yeah, great. ChatGPT. So ChatGPT is a little, it's still a little bit like Alexa, right? And yeah, but it's a minor difference. Harvard, yeah.
Gemini.
Gemini, great. So Gemini and ChatGPT are basically the same kind of large language model. They can achieve very similar performance, and they can do very similar things. Yeah, thank you. What else?
Filters.
Else's? Or what is that?
Like
Uh,
filters and like photoshopping.
Photoshopping? Yeah, I think that is AI as well. That is some AI assistant help you to make picture more beautiful. Yeah, sure. Oliver.
The cars that drive themselves.
Wow, great. Yeah, that is a very good answer. Yeah, so that is autonomous cars is great. And the Zachary. Zachary?
Microsoft Copilot.
Yeah, great. Microsoft Copilot, so it helps you to make better code. So that is great. Yeah, that is awesome. So you have a few named a few AI applications around you. And well, Abigail, do you want to answer?
Rogue.
Grok. Yeah, of course. Yeah, Grok. Gemini, ChatGPT, or the large language models. Yeah. So let's go back to a long way ago. So in fact, the AI was started very early. So basically, because you know that computer was invented during the Second World War. And in fact, AI had evolved a lot. So in the very beginning, it was not like what it looks like today. So it was more like simple rule-based models. And it all started from like 1950 something. So this is the person that is very important. That is Alan Turing. So he asked the question, so can computers think? So that was the first idea to build a computer and try to mimic human. And he was the person who proposed the Turing test. The Turing test is basically saying that if you can talk to a computer and you cannot distinguish it from a real human being, then that that tells you that this computer can be as intelligent as human beings. So that has long been a test that we were trying to use it to verify the level of the AI that we are building. And right now, I think a lot of models have already passed this test. So like ChatGPT, Gemini, Grok, I think they have all passed this test. And this test can be traced back all the way to 1950s. And he wrote the book that was Computing, Machinery, and Intelligence. So that is how, well, I think he was a really genius that tried to combine all these things together, like computing, machinery, and intelligence. So it is not just about doing some binary computing, but he was trying to push it all the way to intelligence. And why it matters is that, in fact, he had that idea that intelligence is not something mysterious. So it is not something spiritual. It is something that you can try to mimic. It is something that you can simulate. I think that was a very big idea. And I think that has transformed the whole field. So that was 1950. And then came to 1956. And this was another very important figure, John McCarthy. And he was the one who named AI. So he basically proposed the term AI. So basically McCarthy, along with Marvin Minsky and Claude Shannon. So Claude Shannon is also a very important figure. So he was the father of the information theory. And we can talk about it later in our later classes. And together with Nathan Rochester. So what they did is that there was a very famous workshop, so that it's called Dartmouth workshop. And they coined the term artificial intelligence and officially launched AI as a field of science. What is important about this is that once it is established as a field, then people can have a goal. So they have set a goal to build the computer to be smart as the human beings. Then people will try to think about it and try to invent a lot of different ways to do that. So basically, this idea was that computer can be taught to think. So if you believe that is achievable, then people will try different ways to do it. Basically, he also introduced the early approach of the rule-based AI. So anyone has any idea of what is the rule-based AI? Rule-based. So for example, I want to teach a child, well, what cannot be eaten and what can be eaten. What is edible and what is inedible. So I will tell him, well, this is apple, this is pear, and this is your shoe, okay? So if you see an apple, apple is edible. And you see a pear, and the pear is edible. And the shoe is not edible. So you cannot bite your shoe, okay? So that is a rule. So when the child grows bigger and bigger, I try to teach him or her more rules, like saying, well, can you eat cherry? Okay. Can you eat other fruit? Right. So when you are referring to fruit, that becomes another rule. So it basically states, well, all the fruit are edible. then the rules get more complicated. And at the beginning, it was saying like, well, I can eat apple, I can eat a pear. And when you generalize it into like all fruits are edible, then it becomes like what is fruit? And if you can classify it as a fruit, then it is edible, right? So these are all the rule-based models that we human beings are familiar with, and we sometimes try to use this to build an AI. So we can see later. So this is the rule-based model. In the late 1980s, late 1950s to 1980s, it was all rule-based expert system. So that is, we were coding, right? So it is basically some if then rules, right? So if I want to decide if something is edible, so I can check all the rules. The rules should contain like if anything is edible, right? So that is one way to do it. So basically, scientists would write thousands of if-then rules to make computer act smart. Yeah, so in fact, even in very recent years, like in Alexa, I think about 2 years ago, it was still rule-based. So basically, it was like millions of rules there. Saying that, well, if you say something, then how can I respond? So it was a huge rule-based model. And to write a rule-based model, you need to code, right? So you need to code it one by one. So that is why we need so many human and software engineers to build this big software, right? And the very first chatbot, ELIZA, expert system in medicine. So it was the name. So it was developed by Joseph Weizenbaum in 1966. So I think back then, I think all the kids here were not born, and it was long ago, and I was not born then. It was a female given them also meaning like a pleasure to God or joyful. So on the right, you can see what it looks like, right? So it would say, ELIZA, it says, is something troubling you? And you will say, well, men are all alike. And ELIZA would say, what is the connection? Do you suppose to, et cetera, et cetera. So it talks, right? So remember the Turing test, right? Do you remember the Turing test? So if in a game, if a computer can pretend to be human in a conversation, then that is basically you cannot distinguish it from human beings. Then it is very successful. So that's the Turing test. So so ELIZA, I think probably you can you can see here that you can answer some questions, right? But can you find a way to tell if it is a human being or a real therapist? Anyone want to volunteer? So can you find a way to tell if the chatbot is real human being or not? So anyone want to volunteer?
Could you mute first?
Yeah, I can.
Okay.
There is some echo.
Could you mute? Oh. Whoops.
Okay, sorry. Problem.
Okay. No echo. You don't hear any echo.
Okay. Yeah, go ahead.
So I've seen like in AI, people are always like worried about like AI and like, bot takeover. So like the people who make them are like the second they find out their second that they find out that like they learned of something slightly inappropriate, they'll like immediately like try to delete it. So you just have to ask it something slightly inappropriate, and it probably won't be able to answer.
So you mean that you change the question a little bit, and then it might not be able to answer, right?
Yes.
Is that your answer? Okay, thank you. Yeah, I think you in like the first rule-based chatbot, that is probably the case because if you think about it, that if you want to build a chatbot like this, how do you do it, right? Yeah. So anyone want to answer this question? So how would you build a rule-based chatbot? Not ChatGPT today, right? But some rule-based simple ones. So how would you do it? So if I give you a task, give you a project, saying that, come on, let's build a chatbot today and show it to your classmate tomorrow, how would you do it? Xuan Xuan, do you want to give it a try? So if you want to build a chatbot, how would you do it? Zhang Xiaobao.
And just the personal questions or something.
I can't hear you, Xuan Xuan.
What?
You break a lot. Okay, no problem. Let's find another. Alisa, can you give it a try? So if you want to build a chatbot, so how would you do it?
Um, uh, um, Can you give me a hint?
So for example, it's like teaching a machine to talk, right? So to chat with you. So probably you just treat it like a little baby, right? Saying that start from something very simple, like hello, right? So if I say hello, then how would you respond, right? So probably we would build something from very simple. Yeah. 橘子老师
Wouldn't I just like ask ChatGPT to do it?
ask ChatGPT to do it. That's a smart way. That's good. Hey. Okay, so that is very smart. So you can link it to ChatGPT, and then it can basically answer any question, right? So in the very big, Oliver, yeah, go ahead.
You have to give the AI lots of information about something if you want to get an answer.
Mm-hmm. So you basically saying, well, I have a question, and this is the answer, right? Question, answer, right? Is that your way? Okay, basically yes. So that is basically how people in the very beginning did it, and we can make it more complex, but basically it is saying that I have a huge database of questions, and I have corresponding answers. So if you ask something in my huge database, then I will respond in this way, right? So in that way, for example, if you are customer service chatbot, and your job is to deal with like the returns and providing information and dealing with like a payment refund or these kind of things, then basically you can predict what people would ask. So they would just ask that kind of question. So that is why when you are calling a customer service through your phone, and it would give you all different kind of options, saying that if you want to do something, then press 1, and if you want to do something, then press 2, etc. Right? So because that is basically rule based. But have you ever think about it, right? If you have a large question database, but it does not cover all the things. It cannot cover everything. If a question is never asked before, like say, like if I suddenly say, have you ever seen aliens? Right? Have you ever go to moon? So how would the chatbot respond?
Hi.
Yeah. Edward, what would your answer?
So the chatbot might not like, it might just error, just like say error on the thing where it replies, and then, or it could just make up like, could just like take a really long time to search, and then it in like a few hours it still doesn't have an answer because it can't find any from the sources.
Okay, yeah. Yeah, that is very good. So this is one possibility. But as a builder, so when we take care of the question that we have never seen before, what we usually do is we just respond like, I don't know, or something like that. So that is basically when you are a builder, how you would deal with all these kind of questions. So as you can see, that is not very smart, right? So because if something that you have seen already, then you can use your system to answer these questions. But if the system get super complex, for example, you have multi-turn, like you are chatting with ChatGPT now, right? So you first say something, then it asks you for clarification, and then you need to answer the questions, and you have multi-turn conversations, just as you are doing with the human beings, right? So, but in that case, basically the system, a rule-based system cannot handle that. So that is why we want to make a shift. So the first shift is from rules to learning. Basically, scientists realized that writing rules by hand wasn't scalable because, as I said, that for Alexa, it was 1,000,000 rules, huge decision tree, but it does not solve all the problems because, as you can see that if you consider multi-turn, you have just as you are talking with the human being. So you ask, and he or she responds, and you ask again, and he or she also responds again. Then in that case, it gets really complicated because imagine that in the first round you have like 1,000 possibilities. And for the second round, you have 1,000 possibilities. Then 1,000 by 1,000 becomes 1,000,000. So that is potentially a 1,000,000 possibilities using just the 2 rounds when you have just the 1,000 possibilities for that. In just one round. So they would ask this question. So scientists began to explore this problem. So what if computer could learn on their own from examples? So you do not to predefine all these kind of rules. So you can ask the mod, ask the computer to learn from it, to learn from data. Okay, so that is the first shift we have. Okay. Okay. So that was the first shift. So it was a shift from rules to learning, to machine learning. So that is how the word machine learning came into being. Okay, and the story of machine learning can trace all the way back to 1958. And that was when Frank Rosenblatt built the perception. So the perception, it was an early neural network that learned to sort simple patterns. So it was very simple. Basically, like it is a operator, so it can do an operation. So the operation is to add all the input, first multiply them by a specific number, and then add them together. So that is the perception that is shown below in the plot. So if you have some interest in math, you are free to look at the formula. Otherwise, it is basically doing some add-ups of the input signal. So in this way, in fact, it is not fixed. So this new, this is very similar to a neutron in your brain. So it is not fixed. It can learn. So if it receives a lot of signals from one channel, then it can learn to strengthen that channel. So that's how your brain build up. And for the perception here, it says that if I receive a lot of signals from, for example, the input one over here, right? So if I get a lot of signals here, then that probably says, well, this is important, right? So I can increase the weight over here for the final signal to make the final signal. So it shows that machine can learn from data, not just follow rules, because this is not fixed. So the output can vary based on the input, and it is not fixed. So after revising the weight here, basically the brain is changed. So it learns from the data and not just from the rules. And then comes the three big masters of deep learning. That is Geoffrey Hinton, Yang LeCun, and Joshua Bengio. So they basically made the system super efficient because when you were back in 1958, the perceptions were already there, but it's not working because the compute was not enough and the system is not efficient. Yeah, Edward.
On the next page, that last dude, that Yosh guy, yeah, that guy, the last one, Yosha Bengo, he looks AI generated.
A little bit. Yeah, it looks too refined, right?
I don't remember what you said at all.
Yeah, so it is somewhat treated. Yeah, I agree. Yeah, so basically the whole system, it becomes very efficient. So it is so efficient that we can build a very bigger and smarter model today. So I have listed some of their important contributions here, and we will touch some of them later in this course. But basically, they are trying to make the brain bigger, wider, deeper, and smarter. And with a huge amount of data, it can be very smart. Okay. And a milestone was in 2012. So that was AlexNet. So AI learns to see. So it was a very powerful neural network that can distinguish 1,000 different kinds of images. So like this is cat and a very specific like short hair cat and a long hair cat, American short hair, etc. So very, very detailed classification of the images. And it was even better than a human being at this specific task back in 2012. So that was a very big milestone. And then came the big language model era, so basically now. And it was because I think someone in Google invented a very smart model that's called Transformer. And built on that, the GPT came into being. Sam Altman, they together built the ChatGPT. So that is how it came into being. So this was a shift from the deep learning models that we learned before, right? And then it's shifting to trillions of words of the whole website. We use all this data to train the model so that the model can understand, can write, can help human, and can really learn how humans think and how humans talk so that it can pass the Turing test. So basically, right now, if you talk with ChatGPT, you cannot. So basically, you cannot distinguish it from a human being. So that is how advanced it is right now. Okay. So let's wrap it up here. So what can AI do? It can do a lot of things. So it can recognize faces. It can draw cool pictures. So it can talk like a person. And also it can play games, no matter if it's chess or Minecraft. And it can sort items very fast because we have robotics, for example, in Amazon. It can help you to separate, to classify different packages. And it can detect animals in pictures. So that would be super fun. And in fact, that's not hard. So we can try to build it today. Okay. So let's go to part 2. So how AI learns. So as we have introduced before, right? So if you can program it, you program AI. So this is the rule. Well, then you can teach it in this way. So these would be very specific rules for very specific task. But we have seen a shift from rule to learning. So we learn through data. So we learn from data. So this is basically what AI model is built today. So you have a data set over here. For example, so this is a picture of an apple, and this is the picture of a banana, and this is the picture of grapes. Right. So I use this data set to as an input to train my neural network. Okay. And my neural network would make a prediction saying that, well, this is, so if I see this picture, so I would say this is a banana. But in fact, it is not banana. So this is an apple, right? So I made a mistake. Then I know that something was wrong. And I can use my mistake to do a back propagation and revise my model so that my model is revised and updated. So basically, I repeat this over and over again. After like millions or tens of millions of images, I began to be very sophisticated with this classification task. Then I become a new model. I become a very sophisticated model that is good at classifying all these images. Okay, so this is basically how AI model learns. Any question? No question? Then I will ask you a question. So what if I make a guess and it's correct? Well, what would it do? So if my model make a prediction and it is correct, what it will do next? And if it is wrong, what it would do next? Zachary, do you want to give it a try? Zachary, are you there?
Sorry, could you say that again?
Yeah, I mean that if my model, after I giving my model a picture, and it makes a guess, right? So it will guess if it is an apple or orange or etc. And if it is correct, what it will do next, and if it's wrong, what it will do next.
You can say, I don't know.
So if it makes the right answer, it'll tell you the right answer. But if it makes a wrong answer, it will probably tell you that.
It will revise itself.
Yeah, it will
Yeah.
like correct itself.
Yeah, exactly. So that is very correct. Basically, the model is learning just like the human beings, right? So if we have done something very well, and we are 100% time that we are correct, then basically we have nothing to learn from it. We are masters already. So it is only through the mistakes that the model can learn, right? So the model is the same as human beings, that we learn from our mistakes. So that is how it works. And the learning process is called back propagation. So it tells you that if I see an error, I need to back propagate it all the way back to the neural network we have seen before. Okay. So this is a big shift, right? We shift from rule-based model to learning model, and then from smaller models to deeper and wider models. And we have a huge amount of data. We can train the model to be very sophisticated in some cases. So the biggest model, for example, like a GPT-4 now, the data is like a billion, trillions of tokens. So trillions means like the whole website. So everything people have written on the website. So everything there. And the performance is thing, like basically it can pass the Turing test now. So you cannot distinguish it from human beings already. So that is something really awesome. Okay. Okay, let's have a 5 minute break. And after that, we will start our hands-on project. Okay. And the hands-on project, I'll give you some clue here. We will build some model. So that would be your first model. The model would be something like this, so you can see it, right? So it would be a classification model. So it would be a face recognition or any recognition, right? So I have inputted two different kind of images. So one is Ethan and one is myself. And with this camera, so it can, so if I input my image here, so it will say, well, most likely it is class 2, right? Let's do it. So it will say class 2 is more likely. And if Ethan is here, Ethan, can you come here? Then it will say, well, this is Ethan. But it seems that since I look so much alike, Ethan, probably the model will confuse. Okay, and we will try to build a model like this later. Okay. Let's have a 5-minute break and come back later. Okay, let's resume. So we will do a hands-on project here. The first part is to do some basic operations. So I want you to open an editor. So I want to make sure that everyone knows how to open an editor. So you can try to answer some questions, right? What is AI? What problem can AI solve? And the name of few AIs around you. But since you have already answered these questions in voice, probably you can skip that. But I want to make sure that you know how to open an editor. So if you are in Mac, then you can do. You can open, for example, a notepad.
I can't see your screen.
Okay. Can you? Okay. Probably you
Yeah, I
can
can
see
see it now.
now. Great. Thank you. Thank you for the reminder. Yeah. So I want to make sure you know how to open an editor. If you don't know it yet, we can try some other ways. For example, through ChatGPT to generate files, but that is just the alternative. But you should know how to open a file and how to make edit it. And the second part is here. I will paste it here. So that would be our main task today. And I'm going to show you how to do it. So this is called teaching machine. So as we have already learned, right? So this basically the model learns from human being, from all different kind of data, right? So that is one, that is how machine learns. And this is a very simple way to build a model and ask the model to learn from data. So after you click into this website, as I shared in the chat, you can see that it will ask you first to log in, right? So log in using your Google Drive, using Google account. And then there are three kinds of project here. So number one is image project. And then number two is audio project. And number three is a post project. So we will be using the first one, the image project here for simplicity. So click on it, and it will ask you to choose from two different kinds of projects. So on the left is the standard image model, and on the right is the embedded image model. Embedded image model is something smaller because you see that it will have, it can handle 96 by 96 pixel grayscale images. And it is a small model. And the model size is about 500 kilobytes. But by comparison, the standard image model, it will handle images up to 224 by 224, and it is colored images. So on the left, it is colored images. On the right, it's grayscale images. So that is smaller because it only has 2 channels. And this one, it will export to TensorFlow, TF-Lite, and TF.js, and the model size is about 5 megabytes. So it's much bigger. So it's 10 times bigger than the right one. So it's the same model, the same functionality. The left part, the model would be 10 times bigger, but more powerful because it can deal with bigger images. So it is more refined. Okay, so we will choose the bigger model, the standard image model. And then it will ask you to add classes, all right? So this is a model to make a classification. So we can, for example, I can make a model to distinguish between myself and my palm, okay? So it could be anything, So let's first add the images for the first class, okay? So let me take a record of myself. So try to take yourself, take more images in different directions. Okay, so it learns, well, this is me. Okay, and I can put a class name here that is, right? And the second class is like a cell phone. Okay, so a cell phone. So we can take just my palm. So let's first. Let's just click on the second class and hold to record. Okay, and rotate it to give it more direction. Okay, and I can say this is palm. Palm. And then click on train model. So it will say that there are 50 steps, and you can wait for a little while. Don't switch tabs, just wait. It's very fast. Okay, and then you can see here is the output. The output. The input is web camera, and you can have your output over here. So it says, well, this I'm 100% that this is Kai, okay, and only 0% that this is Kai's palm. So how about now? Well, in this case, it says, well, this is Kai's palm, and once my face is in, you see that it will recognize me. And you can think about different kinds of use cases. Okay, for example, it is your turn to innovate and try to think about it, what you can do. So basically, you using all this data, you have built a model to distinguish two different kinds of things. Or okay, and you can export the model. So it will say that export your model. So you need to first upload it, because it can upload the model to a Google Drive. And so after you have trained the model, you can click on the upload my model and waiting for it to finish. It will say your cloud model is up to date. Okay, so basically right now you have a link here, and down here there is some code snippet to use your model. So you can directly copy it, and as we have done before last time, you can open your editor and put all the text into your editor, right? So for example, if you do not have editor, but you have ChatGPT, then let's go to ChatGPT. You put a new chat over here, and then you just paste it here, and tell ChatGPT will generate a HTML file from the above. Then it will give you HTML file for download. Just to say generate the HTML file. Once it says analyzing, then okay. Okay. So then you have a download a teachable machine model. Then you can open it. And directly you can start and wait a few seconds. It will ask you to give access, and it can just do it. Then you can combine this one to the website you made last week. Yeah. Okay, so this is the project for today. Everyone clear? If you have questions, please ask now. Is everyone clear?
Yes.